Q7185. During a winch launch, which factor would most likely result in pitch oscillations? A. Winching speed too fast. B. Winching speed too slow. C. Insufficient up elevator control. The correct answer is C. Winch launch. A winch launch is a method of launching a glider using a ground-based winch to rapidly reel in a cable attached to the glider. The winch generates a strong pulling force to provide the initial acceleration for takeoff. Pitch oscillations. Pitch oscillations refer to repetitive and alternating changes in the pitch attitude of the glider, causing it to pitch up and down rapidly. Elevator control. The elevator is the primary control surface on the tail of the glider that controls the pitch attitude. By moving the elevator, the pilot can adjust the angle of the glider's nose, affecting its pitch. Insufficient up elevator control. That pitch oscillations during a winch launch are most likely to occur when there is insufficient up elevator control. This means that the pilot does not have enough control authority or movement in the elevator to counteract the forces and maintain a stable pitch attitude. Balancing forces. During a winch launch, there are various aerodynamic forces acting on the glider, including the upward force generated by the wings, lift, and the force applied by the winch, pulling force. The pilot needs to apply appropriate elevator control to balance these forces and maintain a stable pitch attitude. Impact of insufficient control. If the pilot does not have sufficient up elevator control, it becomes challenging to maintain a stable pitch attitude. The glider may experience pitch oscillations, where it alternates between pitching up and down rapidly, leading to an unstable and potentially unsafe flight condition. Based on this reasoning, option C accurately states that during a winch launch, pitch oscillations are most likely to occur due to insufficient up elevator control. 7189. With regard to two or more gliders flying in the same thermal, which statement is true? A. All turns should be to the right. B. Turns should be in the same direction as the highest glider. C. Turns should be made in the same direction as the first glider to enter the thermal. The correct answer is C. Flying in the same thermal. When multiple gliders are flying in the same thermal, it means they are all utilizing the same rising column of air to gain altitude. Consistency in turns. To maintain safety and coordination, it is important for the gliders to follow a consistent pattern of turns while flying in the thermal. This helps in avoiding collisions and maintaining proper spacing between the gliders. Direction of the first glider. Turns should be made in the same direction as the first glider to enter the thermal. This means that the initial glider to find and enter the thermal determines the direction of turns for all subsequent gliders joining the thermal. Coordination and avoiding collisions. By having all gliders turn in the same direction as the first glider, it ensures a synchronized and predictable pattern of movement within the thermal. This helps in maintaining proper spacing and reducing the risk of collisions between the gliders. Efficiency and sharing lift. Following the turns of the first glider allows the subsequent gliders to benefit from the lift created by the thermal. The first glider helps indicate the most favorable direction for turning within the thermal, maximizing the efficiency of all gliders in utilizing the rising air currents. Based on this reasoning, option C accurately states that with regard to two or more gliders flying in the same thermal, turns should be made in the same direction as the first glider to enter the thermal. This promotes coordination, safety, and efficient utilization of the thermal's lift. 7190, which is true relating to the direction in which turns should be made during slope soaring. A. All reversing turns should be made to the left. B. AI turns should be made downwind toward the slope. C. AI reversing turns should be made into the wind away from the slope. The correct answer is C. Slope soaring. Slope soaring is a technique used by glider pilots to harness the upward air currents generated by wind hitting a slope or ridge. The glider gains lift by flying close to the slope and utilizing the vertical airflow. Reversing turns. Reversing turns refer to the change in direction made by the glider while flying along the slope. These turns are necessary to maintain the glider's position and make successive passes along the slope. Turning into the wind. All reversing turns should be made into the wind, away from the slope. This means that when the glider needs to change direction, it should turn towards the direction from which the wind is blowing. Maintaining position and lift. Turning into the wind during reversing turns helps the glider maintain its position relative to the slope. This allows the glider to stay in the area of maximum lift, where the wind hits the slope and generates the strongest upward airflow. Wind gradient. When flying close to a slope, there is typically a wind gradient, which means that the wind speed may vary with altitude. By turning into the wind during reversing turns, the glider takes advantage of the headwind component at higher altitudes, which provides additional lift. Safety and control. Turning into the wind also enhances control and stability during reversing turns. It helps counteract the effect of the wind pushing the glider away from the slope and allows for better maneuvering and positioning. Based on this reasoning, option C accurately states that, during slope soaring, all reversing turns should be made into the wind away from the slope. This ensures the glider maintains position, maximizes lift, and maintains control and stability while flying along the slope. 7193. When making an off-field landing, it is recommended that the landing be accomplished A. In pastures which are seldom cultivated. B. Uphill, if possible, regardless of the wind direction. C. In cultivated fields where the crops have not yet been harvested. The correct answer is B. Off-field landing. An off-field landing refers to a situation where a pilot is forced to land an aircraft outside of designated airports or landing areas. This could be due to various reasons, such as an emergency or the unavailability of suitable landing sites. Uphill landing. Landing uphill provides several advantages in an off-field landing scenario. When landing uphill, the incline of the terrain helps reduce the ground speed of the aircraft, allowing for a shorter landing distance and a more controlled touchdown. Energy dissipation. Landing uphill allows for better dissipation of the aircraft's kinetic energy upon touchdown. The slope of the terrain helps slow down the aircraft more effectively, minimizing the risk of overshooting the landing area or encountering obstacles beyond the touchdown point. Safety and control. Uphill landings can enhance safety and control during off-field landings. The uphill slope helps increase the angle of attack, which can provide additional lift and improve the aircraft's ability to flare and reduce the descent rate during the landing. Wind direction. The uphill landing should be performed regardless of the wind direction. This is because landing uphill helps mitigate the effects of crosswinds. The uphill slope provides a natural windbreak and reduces the crosswind component, making it easier to maintain directional control during the landing. Terrain assessment. It's essential for pilots to assess the terrain carefully when making an off-field landing. Factors such as the slope gradient, obstacles, and the condition of the terrain should be considered to ensure a safe and successful landing. Based on this reasoning, option B accurately states that when making an off-field landing, it is recommended to land uphill, if possible, regardless of the wind direction. Landing uphill helps dissipate energy, improves control, and reduces the risk of overshooting the landing area. It provides a safer and more controlled landing option in an off-field situation. 7194, which would most likely ensure a safe off-field landing. A. Landing into the wind, regardless of the type or slope of the terrain. B. Landing in a pasture or uncultivated field rather than one in cultivation and whose crops have been harvested. C. Maintaining an approach airspeed of at least 50% above the glider's stall speed plus half the estimated wind speed. The correct answer is C. Approach airspeed. The approach airspeed is crucial during landing as it determines the control and maneuverability of the aircraft. Maintaining an appropriate approach airspeed is essential to ensure a safe touchdown and control during the landing phase. Stall speed. The glider's stall speed is the minimum airspeed at which the wings generate sufficient lift to maintain controlled flight. It is important to stay above the stall speed to prevent a loss of lift and potential stall during the landing. Increased approach airspeed. Maintaining an approach airspeed of at least 50% above the glider's stall speed plus half the estimated wind speed. By increasing the approach airspeed, there is an added margin of safety to account for wind gusts, variations in wind speed, and other factors that can affect the aircraft's performance during landing. Safe landing. Maintaining an appropriate approach airspeed above the glider's stall speed, along with factoring in the estimated wind speed, helps ensure that the aircraft maintains sufficient lift and control during the landing. It allows for better handling of crosswinds, improved energy management, and a more controlled touchdown. Based on this reasoning, Option C accurately states that maintaining an approach airspeed of at least 50% above the glider's stall speed plus half the estimated wind speed would most likely ensure a safe off-field landing. This approach accounts for the specific characteristics of the glider, wind conditions, and provides a margin of safety during the landing phase.